In the previous lecture we discussed speech perception. So this is going to be the second part of speech perception. Speech perception means listening. So listening skills, what are the processes inside your mind as you are listening? Today we are going to continue our discussion on speech perception. We are going to discuss lexical access. The contents for today's lecture are, first we are going to have a recap, a quick revision, then we are going to discuss possible versus impossible non-words. The third element is morphemes. The fourth is cohort model for lexical access. Okay, let's take the first part. Recap from lecture number 4. Lexical decision experiments. That is, we have discussed two types of lexical decision experiments. The first is lexical decision tasks, and the second is priming. This is from lecture 4. These two types of experiments are used to discuss the brain's access to lexical items. So today we are going to discuss how does the brain function while you are listening to texts, while you are listening to someone speaking. What happens inside the brain? In the previous lecture we discussed some processes. Today we are going to discuss lexical access. So known words, this is also a revision from lecture number 4. Known words are easier and faster to access than unknown words. So if the words you are listening to are known to you, you know them before, it is going to be easier for your brain to retrieve these words. And understanding the text is going to be a lot easier than in comparison to listening to texts which includes words which you do not know. So the first part is impossible non-words versus possible non-words. These are two types of non-words, two types of words which do not or which cannot be found in the lexicon. So if you search the dictionary, you are not going to find these two types of words. These two types of words do not appear in the dictionary. They are not part of the lexicon. There are two types of words which cannot be found in the lexicon, which are not even real words. There are two types. There are words which yes, do not appear in the lexicon, which are not part, for example, they are not part of the English words, but they can be added because they are not violating the phonotactic rules. So the first element we are going to read now is, or the first category, the first description of possible non-words. They're called possible non-words because they can be added to the dictionary. So the first category is that they are not found in the lexicon of a language. The second, they are not violating the phonotactics or phonological rules of the language. Yet they are non-words, they are not words. They are just strings of letters or phonemes which can be added to the dictionary, but yet they do not mean anything. They are meaningless. They are not part, for example, if you are talking about English, they are not part of the English language. Examples of these possible non-words is ramp, fluff, and joy. These are meaningless. They are not part of the English dictionary. They are not part of English. They are just imaginary words. They are called possible because once you read them, you think they are English, but they are not. Okay, ramp, fluff, and joy. The second category is impossible non-words. Impossible non-words, they are not part of the English language, and they cannot be added to the English language. This is the trick. This is the main difference. Can this non-word be added to English or not? Impossible non-words cannot be added to the English language because they are violating the phonotactics of English. For example, ترجاز, this does not appear to be English. Shukal, Tlat, Zna, they don't appear to be English. They are not part of the English language, and they are impossible to be added to the English language. Why? Because they are violating the phonotactics of English. We are studying psycholinguistics, and we have just mentioned some differences between impossible and possible non-words. So since we are studying psycholinguistics, what difference can we expect between these two types of words, of non-words? Here we have a question: do our brains react differently to these two types of non-words? So if you listen a non-word such as ramp and another non-word such as turjaz, one is adherent, complies with the English rules, and another which does not comply with the English rules. Does your brain react the same or not? This is the question we have. Do our brains react differently to these two types of non-words? We have two facts. The first, it takes longer to decide that possible non-words are not real. So if you are taking a lexical decision experiment, which we have explained in lecture number 4, it is going to be a bit difficult for you to decide whether a possible non-word is real or not. So this looks like that the retrieval system conducted an exhaustive, ultimately unsuccessful search for the entries in the lexicon. It would be a lot more easier to decide that an impossible non-word is not real, because by just looking at it you can easily tell that this is not English. Okay. The second fact we have when we compare possible versus non-possible words is that brain imaging experiments measuring blood flow in the brain show that the active areas when exposed to possible non-words are different to the areas activated when exposed to impossible non-words. This is a study done by Peterson. What this means is, if we have a look at the brain, where does the blood flow inside your brain, as you are listening to an impossible non-word, the active areas are going to be different to those areas when you listen to a possible non-word. So these two types, of course, these two types appear to be different. Once you look at them, they have differences, and this difference is because inside your brain they are represented differently. So your brain recognizes or reacts to these two types of non-words differently. The second thing we are going to discuss today is morphemes. First, what is a morpheme? A morpheme is the smallest meaningful unit of language. For example, teach is a morpheme, and the ER at the end is another morpheme. Okay, there are two types of morphemes. There's bound morpheme. Okay, there's bound morpheme which is at the end. At the end, ER. This is bound. It is called bound because it cannot stand on its own. So what happens to derived words, that is, words created by adding bound morphemes to them? For example, teach. Here we have a word, teach, the verb, and we can create another word from this verb by adding ER at the end, and here we have a noun, teach and teacher. What happens to derived words such as teacher during speech perception? As you are listening to someone and you hear the word teacher, what happens inside your brain? Does your brain retrieve the word teacher, or first retrieve the word teach, then adds ER to it? If the derived form, for example, teacher, is created by adding a morpheme, that is ER, to a stem, teach, So I'm just explaining the process. Here we have the word teacher, which is composed of two morphemes, teach and er. The morpheme must be removed before the stem is accessed. What this means is your brain removes bound morphemes as you are retrieving words. Okay, as you are listening to someone and you are trying to retrieve, to access the lexicon inside your brain, what happens is you are doing something called morpheme stripping. What is morpheme stripping? It is splitting the bound morphemes from morphemes. In other words, the bound morphemes are removed before the lexicon is accessed. Alright? So this is a process which happens inside your brain as you are listening to someone and you are recalling words. You are removing bound morphemes from the stems, and so that you can retrieve them. Once you retrieve them, you can link them back together so that you understand the text. This is again, I've mentioned this before a couple of times. This is a process which happens in a split of a second. This happens so quickly that you cannot notice it. You cannot even notice this. The third thing we are going to discuss today is the cohort model of lexical access. First, what is the meaning of the word cohort? A word's cohort consists of all the lexical items that share the initial sequence of phonemes. As you can see, some words, as you know, because now you are on an advanced level of learning English, you must have noticed that some words look similar. Some words are similar. For example, click, clip, and cliff. These three words share the same initial sequence. Here we have three phonemes at the beginning, k, l, and the short e, click. So these three words, click, clip, and cliff, share the first sequence of phonemes. They are called cohort. Cohort means the set of words which share the initial sequence of phonemes. So these three words are in cohort. The cohort model of lexical access provides an explanation for the quick recognition of words during perception. So what happens as you are listening to someone? What happens to these words which share the same initial sequence of phonemes? What happens is your brain, as you are listening, activates the similar words. For example, this happens so quickly, in a split of a second, or perhaps less than that. Let's assume that you are listening to someone. What you hear is clip, clip. Okay, the first part of the word. You are activating the similar words. You are activating the cohort. You are activating the words which share the same initial sequence, and deactivating the rest of words. For example, you heard someone saying clip. Okay, you activate a number of words. Some of them are click, clip, cliff. You are activating these. Activating these three words or more, activating the cohort, enables you to retrieve words easier and faster. Alright? At the same time, you are deactivating the rest of words. For example, we have the word drive. The word drive starts with a different initial sequence of phonemes. You are deactivating the word drive. You are deactivating the word, for example, mouse. You are deactivating the word computer, because they do not have the same initial sequence. So what happens inside your brain is that as you are listening to the speech, you take the first part, you activate the similar words. This happens so quickly. You activate the similar words and deactivate the words which are not similar. Let's read what we have here. Acoustic information is rapidly transformed into phonological information. and lexical entries that match the stimulus. The stimulus is the first initial sequence. Lexical entries that match the stimulus phonologically are activated. Alright? So as you are listening to you are activating click, clip, cliff, and all the rest of words which have the same initial sequence, and deactivating the rest of English words. A factor that affects retrieval times of words is neighborhood density. What we mean by neighborhood density is the number of words which share the initial sequence. Sometimes some words have, or sometimes you have an initial sequence and there's just one other word in English which share the same initial sequence. For example, the word zero, which means in Arabic صفر, the word zero, I think there's just another word for it in English, Xerox. So as you are listening to someone saying zero, you are activating just one word, two words, sorry, zero and Xerox. Alright? This initial sequence has a very low neighborhood density, just two words. Some words have a high neighborhood density, have a very large number of words, of cohort words which share the same initial sequence. A word's neighborhood consists of all the lexical items that are phonologically similar. Right? Let's have this exercise together. Before lexical retrieval, bound morphemes are kept, removed from the word they are bound to, only kept if they are derivational morphemes, or only kept if they are inflectional morphemes. So what happens as you are listening? What happens to words which have bound morphemes? Are they kept? Are the bound morphemes kept? Are they removed? Or are they sometimes removed and sometimes not? I'm going to give you some time to think of an answer. The answer is, right? Actually, the answer is B, not A. So this is a mistake. The answer is B. Mistakes can happen. Apologies for this mistake. The answer is B. Why? Because as I have said earlier, morpheme stripping. Where is morpheme stripping? Alright, I'm looking for, yes. As I said earlier, morpheme stripping, bound morphemes are removed before the lexicon is accessed. Okay, so what happens is, before lexical retrieval, bound morphemes are removed from the words they are bound to. Thanks very much for listening. Thanks.